starting a channel of maths just to clear your doubts if you are at home, and on a very clear note, maths is something to be enjoyed. One cannot take pressure of it, one cannot take burden of it. So maths, once you know, once you practice properly, then you will have a command on it for sure. So the basic thing about maths is first understanding. Second, if at all you have doubts related to a particular topic, a particular subtopic, then those should be clear. And third, you should do practice by solving. For that, book and pen should be your friends. So these three things if you follow, you will never have a problem in maths. So to learn maths, I strongly feel that maths is totally based on a topic called trigonometry. A very important topic of maths. Today we are going to learn about trigonometry, the topic which you have studied in 9th standard. Basics you have learned in 9th standard. In 10th, those basics to be used and to be applied. So let us revise the few basics of 9th standard. First, the relations which you have studied in 9th standard. Sin theta into cosec theta is 1. Second, cos theta into sec theta is 1. Third, tan theta into cot theta is 1. Fourth, tan theta is sin theta upon cos theta. Fifth, cot theta is cos theta upon sin theta. Now in 9th, in our syllabus, we have only sin, cos and tan. The three terms, that is cosec, sec and cot, we don't come across in 9th standard. But what are they? Basically, cosec is a reciprocal of sin. That's why cosec is 1 upon sin theta. Sec is a reciprocal of cos. That's why sec is 1 upon cos theta. And cot is a reciprocal of tan. That's why 1 upon tan theta. So, the values which you have studied in 9th standard, the table, 10th standard, we normally don't require values of cos. We don't require values of cosec, sec and cot for solving problems. We require normally values of sin, cos and tan. But the table which you have studied, if at all you go through the table, you will come to know if by just reversing, taking the reciprocal of those values, you will get values of the remaining three ratios. So, to start with, as discussed, let us come to the first exercise of the textbook. Now, before I go to that exercise, let us first prove this relation. Sin square plus cos square is equal to 1. Now, these 5 relations we have studied in 9. Now, there are 3 more relations which we call as identities, which we will learn in 10th standard. Now, to prove this, in a very rare case, the proving will come in exam. Very, very rare case. Normally, it is the application of this particular identity. So, as we all know, that trigonometry is only applicable to a right angled triangle. Only applicable to a right angled triangle. So to prove this, let us take an angle as theta. Not necessarily this is theta. it can be angle A also as theta. It is your choice. Now, the definition which we have studied in 9th standard, try to recollect those definition. Sin theta. What is sin theta ka definition? It is opposite upon hypotenuse. So, opposite side of what? Opposite side of the angle half. In this case, it is theta. So, which is the opposite side? It is AB. Hypotenuse is a standard or a fixed side in a right angle triangle. What is an hypotenuse? An hypotenuse is a side opposite to 90 degree. Always, it won't change. And that is why in this case, it is AC. Similarly, by definition, cos theta. What is cos theta by definition, which you have studied in 9th standard? Adjacent upon hypotenuse. Again, adjacent side of what? Adjacent side of the angle. So, for this angle, the side besides the angle is the adjacent side. There are two sides actually besides it, BC also and AC also. But AC we can't take because AC is a hypotenuse. It is opposite to 90 degree. So the only one remaining adjacent side is BC, and that's why BC upon AC. Now, as we are trying to prove that particular identity, let us take the LHS of it. That is sin square theta plus cos square theta. Now, sin square theta. I am explaining this particular term. What is the difference between these two? Sin square theta and sin theta square. These are two different terms. They are not equal. They are not equal at all. Why? Because when I say sin square theta, it is square of the trigonometric ratio. It is square of the trigonometric ratio. And when I say sin theta square, it is square of the angle. It is square of the angle. So please remember, this is not equal to sin theta square. This is not equal to sin theta square. So let us come back again to the identity. Sin theta we have got by definition as AB upon AC the whole square. Cos theta by definition is BC upon AC the whole square, which is AB square upon AC square plus BC square upon AC square. As the denominator of both is same, it will be AB square plus BC square. But it is a right angle triangle, and in right angle triangle, in this case ABC, we can obviously write AB square plus BC square is equal to AC square. The famous theorem, Pythagoras theorem. Pythagoras theorem. And therefore it will be AC square upon AC square, which will be equal to 1. So we got an identity, sin square theta plus cos square theta is equal to 1. There are two more identities. Second one is 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. Same way, by using the definition, we can prove these two identities. As I said, this proving of identities is there in the textbook, but normally not asked in the exam. But these three identities you have to remember properly, because it helps us to solve the proving wala problems. So let us solve 6.1, our first question. In the exam, they will give sin theta is equal to, or cos theta is equal to, or tan theta is equal to. This is the solving of our textbook, 10th standard, our government textbook 6.1, question number 1. Sin theta is equal to 7 upon 25 they are given, and they say find the value of cos and tan. Not necessarily they will say cos and tan, it can be cos, tan, cosec, sec, cot, all other than sin they will tell us to find, not an issue. Now, because we have sin theta and we know we have an identity sin square theta plus cos square theta is equal to 1, so we can use the same identity. Sin square theta plus cos square theta is equal to 1. As it is an identity, please write identity. Substitute sin का value, sin upon 25 the whole square plus cos square theta is 1. So cos square theta is 1 minus square of this, and we'll take it on the right side. It is 49 upon 625. As you have taken it on the right side, positive becomes negative. Then the LCM. So 625, 1s are 625 minus 49 upon 625. 625 minus 49 is 576 upon 625. That is cos square theta. So what will be cos theta? It will be square root of 576 upon 625. So cos theta will be 24 upon 25. So we got cos theta by using the identity. Now we want tan as per the question. What is tan theta? It is sin theta upon cos theta. Sin theta का value is 7 upon 25. Cos theta का value is 24 upon 25. 25 will get cancelled. So what we get tan is? Tan is 7 upon 24. This is the way we solve a value wala problem. If at all, by any chance, instead of sin, they are given tan, or for that matter, cot, as in our question number 2 and 3. Let us solve the question of third one, where they have given the value of cot. Okay. So, the third question of 6.1, they have given a value of cot theta. Cot theta is 40 upon 9. And they have asked the values of cosec and sine. Cosec and sine. Again, if I know cot theta and if I want cosec theta, I use the third identity which says 1 plus cot square is equal to cosec square. So, 1 plus cot square is equal to cosec square theta. Identity. 1 plus cot is 40 upon 9 the whole square is equal to cosec square theta. 1 plus 40 ka square is 1600 upon 81 is equal to cosec square theta. Taking the LCM, 81, 1 into 81 is 81, 1600 cosec square theta, so 1681 upon 81 is equal to cosec square theta. So cosec theta will be square root of 1681 upon 81. 1681 is the square of 41. And 81 the square root is 9. So we got cosec theta. We also want sin theta. As we know, cosec and sine are reciprocals of each other. So sin theta into cosec theta is equal to 1. So cosec sin theta will be 1 upon cosec theta, which will be 1 upon 41 by 9. Which is 9 upon 41. That is why at the start I said, if you know those 5 relations which you have studied in 9th standard, these 3 identities properly, then we can easily solve any given problem related to the values. And it is very much necessary. As we are in 10th standard, we have to solve these questions by using identities and formulas. We cannot use the method of 9th standard. Though it is easy, but it has to be solved by this method. By any chance you solve it by 9th standard method, you will lose marks for sure. Now the very important part of trigonometry, that is proving questions. Proving questions. Okay, before we go for a proving question, there is question number 4 in our textbook 6.1 chapter. They have given a relation 5 sec theta minus 12 cosec theta is equal to 0. And they want us to find cot, cos and sin. Fine. But when such questions are framed, don't panic, because as the numbers are there as the coefficient, by simplifying you will get a ratio. A trigonometric ratio is equal to a particular value, a fraction. So for that, what to do? 5 sec theta is equal to 12 cosec theta, minus becomes plus. Bring trigonometric ratios on one side and the values on the right hand side. So it will become sec theta upon cosec theta is equal to 12 upon 5. 90% of the time we are in a hurry in an exam, and by default we write it as 5 upon 12. Please remember, after we write it, okay, not an issue. Hurry ho sakta hai, anyone can make a hurry, negligence possible hai. I request only one thing: the moment I write this step, before you move on, please check that after cross multiplication, am I getting the previous step? That itself tells you whether you have done it right or wrong. See, 5 into sec, 5 sec theta, cosec into 12, 12 cosec theta. So we are right. By any chance, if you would have written it as 5 upon 12, you will come to know, oh, there is a mistake. So to avoid, please cross check. Now, second cosec. In trigonometry, if I want to simplify anything, the easiest way of simplification is convert everything to sine and cos. Because all the ratios are related to sine and cos. We know cosec is a reciprocal of sine, sec is a reciprocal of cos. So let us write. Sec is 1 upon cos, cosec is 1 upon sine is equal to 12 upon 5. This denominator will go to the numerator, or else I'll put one more step. 1 upon cos theta into sine theta upon 1 is equal to 12 upon 5. Division by any number is multiplication by its reciprocal. That is the rule of maths, right? So I did the same. So we got sine upon cos is equal to 12 upon 5. And what is sine upon cos? It is tan theta. So in the first question they are given sine ka value, we calculated cos, we calculated tan. In the third question they gave cot ka value, we calculated cosec, we calculated sine. Now a relation, maximum, as we say, normally students have a habit saying this problem is outside the textbook, unnecessary, there is a fear. Maximum in such particular question, what they will do, instead of sec and cosec, they may ask you sine and cos, they may ask you tan and cot. No problem. Solve, apply the formula correctly, simplify it correctly, you will get a trigonometric ratio equal to a fraction. The moment I get tan, now what they want us sec, cos and sine. We all know we can find sec from tan, because we have an identity. We have 1 plus tan square theta is equal to sec square theta. So it is 1 plus 12 upon 5 the whole square is equal to sec square theta. So it is 1 plus 144 upon 25 is equal to sec square theta. LCM 25. So it is 25 plus 144 is equal to sec square theta. So it is 169 upon 25 is equal to sec square theta. So what will be sec theta? It is square root of 169 upon 25, which is 13 upon 5. Now the interesting part I'll share, those who are inclined towards maths or have a planning in 11th standard, I'll take science. Then science has trigonometry in maths. If you take commerce in that maths, there is no trigonometry, but science may have. And because it is there, again, there is a chapter called Trigonometry 1, Trigonometry 2. It is an extension of this. What is an extension? Presently. A very basic question one can have. We are taking square root. Why we didn't do plus or minus? Now this plus or minus will come in 11th standard. Because there you will learn the quadrants and the signs of this particular trigonometric relation, particular quadrants. Presently it is not in our syllabus, it will come in 11th standard. So you come across that particular thing when I post a video of that particular chapter. Presently, sec theta, we got tan and sec. Now we want cos. So if I know sec theta, we can find cos theta, because sec theta into cos theta is 1. They are reciprocals of each other. So 13 upon 5 into cos theta is 1. So cos theta will be 5 upon 13. So we got cos theta, and then we want sin theta. Now to calculate sin theta, we have two ways, two methods. One, by using cos theta, because they have an identity. Sin square plus cos square is equal to 1. We can get it. Otherwise, we have a tan theta value also and a cos theta value also. By using a relation, tan theta is equal to sin theta upon cos theta. We can use this relation because we know tan, we know cos, we want sin. Now, whenever such framing is there and you want to calculate a sine or a cos, never ever substitute the values first, because 90% of the time in a hurry when we substitute values, then multiplication and division writing you can make a mistake. So you avoid it. So for that, only write trigonometric ratios. Tan theta into cos theta is equal to sin theta. Cos multiplies to tan. Now you substitute the values. What is tan? It is 12 upon 5. What is cos? It is 5 upon 13 is equal to sin theta. 5 gets cancelled. So sin theta is 12 upon 13. So we got all the values related to that question. I hope till here you have understood the basic questions of trigonometry which can be asked in exam, and you have understood how to solve it by using the 5 relations and 3 identities. When you are preparing trigonometry, it is very, very important that you write these 5 relations and 3 identities at the start, and then only start solving chapter trigonometry. In fact, as a practice, you should write these particular 5 relations and 3 identities daily one time. It helps you a lot for remembrance, and if you have remembered it properly, you can apply it correctly. Now, to move to the next part of this exercise, which is proving. For that, again, these identities, these formulas are required. So let us write those particular formula again as a list here. Sine into cosec is equal to 1. Cos theta into sec theta is 1. Tan theta into cot theta is 1. Tan theta is sine upon cos theta. Cot theta is cos theta upon sine theta. And then the three identities. First one, sine squared plus cos squared is equal to 1. 1 plus tan squared is equal to sec squared. And third one, 1 plus cot square theta is equal to cosec square theta. Now let us solve the questions, the proving fifth ka first or sixth ka first. Prove that. Now, in exam when a prove that question comes, whatever question is framed in the paper, write it as it is with prove that. You can write PT or you can write prove that. The question is sine square theta upon cos theta plus cos theta is equal to sec theta. Now, trigonometric proving is not very difficult. Students find it difficult because students want to by heart it. Don't buy it. It's very, very simple if you apply it correctly. The only thing may change is if I am solving a particular problem within 3 or 4 steps, you may take a bit more steps, maybe 3 or 4 more steps. That's fine. Ultimately, we want a correct result with respect to the right hand side. Now, when we are solving trigonometry, 90% of the questions will be solved by converting LHS or RHS to sine and cos. One. Secondly, we observe a trigonometric problem of proving. One should properly identify whether I can directly apply the identity in that question or not. Means, if on the left hand side there is tan square and the right hand side has sec square, yes, I will go for identity because 1 plus tan square is sec square. If on the left hand side there is cosec square and on the right hand side there is cot square, yes, I will go for identity because 1 plus cot square is cosec square. For this to apply or for this to notice, observe correctly, one should know the identity properly. If there is no identity applied proper, we can't apply to a particular problem directly, then 90% of the time we will solve it by converting everything to sine and cos. There are few questions other than these two where we apply a particular method related to that particular problem. Because any other method applied, you may find it difficult to simplify and you may not get the answer. So now in this particular problem, LHS sine square upon cos theta plus cos theta. What I am stating now, if you follow, it will help you. I always solve a particular trigonometric problem related to the right hand side. I'll observe right hand side constantly. Now presently right hand side there is sec. There is sec. A single term, and there are 2 terms in the left hand side. Means what to do? Obviously, I'll convert these 2 terms to 1 term. Now, conversion of two term to one term is only possible by taking the LCM. So I took the LCM. There is no denominator here, so I took cos. The numerator will remain as sine square because the denominator is same. Plus, here there is no denominator, we have changed it to cos. So obviously the numerator of cos will be multiplied by this cos, and cos into cos will be cos square. We know sine square plus cos square is 1. So 1 upon cos theta. This is very important. If you don't write this in the bracket, you will lose marks. Whichever identity you are using or a formula you are using in trigonometry should be mentioned in that step. What is 1 upon cos theta? We know it is sec theta. Why? Because of the relation. Sec theta into cos theta is equal to 1. And what is sec theta? The right hand side is equal to the RHS. Therefore, now, while solving at home, while practicing, you need not write this step which I am writing. But in exam, you should write this relation. Therefore, sine square theta upon cos theta plus cos theta is equal to sec theta. And you can make a log. It looks good, effective, impressive. Okay? Let us go to the second question. Is a direct relation, an identity can be used there. Then the third question, prove that square root of 1 minus sine upon 1 plus sine is equal to sec minus tan. Now this particular problem, many times students solve by taking RHS and then reaching LHS, which is, I think, bit confusing also, and you may find problems when you are particularly solving that type of method. I would prefer to take LHS, solve it, and get RHS, because this tells me I have to remove the square root from LHS, because on the right hand side there is no square root. Now removing a square root is very easy. Getting a square root is a challenging job. So for that matter, I will start with LHS. Now please remember, this is that third type of question which has to be solved by this particular method only. Okay? Now, what is the method? As it has a square root and I want to remove the square root, a square root can be removed only there is a square inside. Square root of 4 is 2, square root is removed. And 4 is the square of 2. So inside the square root, if there is a square, then the square root sign will vanish. So I have to get a square inside. Now, how to get a square? For that, what to do? What will be my next step? Again, I observe the right hand side. What is right hand side? Sec theta minus tan theta. Does it have a denominator? No. It doesn't have a square root also, nor the denominator. Now, if I don't want this denominator, I can only remove this denominator by making a square. To make it a square, because it is 1 plus, obviously I have to multiply by 1 minus. And what is that? Plus ka minus, rationalizing. So I should rationalize the denominator. So 1 minus sine theta upon 1 plus sine theta into 1 plus sine theta upon 1 plus sine. I just can't multiply denominator for 1 plus sine. I have to multiply to numerator also. Otherwise, I am changing the question, which I am not allowed to do so. So now, under the root sign, if you observe, it is 1 minus sine. Sorry, it should be minus, rationalizing, plus ka minus. So, now in the numerator what it is? It is 1 minus sine theta the whole square, and denominator mein it is a square minus b square. A plus b into a minus b is a square minus b square. We can write that particular identity in the bracket. So, unless and until both the terms are properly square form, you don't remove the square root. You can't take the square root. Presently, this is in square form, but this is not because there are two terms. You can't take square root of 1 square minus sine square as 1 minus sine. No, there is a negative sign here, so that is not allowed. So I'll write the numerator as it is. What about the denominator? 1 minus sine square theta is cos square theta. The identity sine square plus cos square is equal to 1. Now we can remove the square root because there are squares in the numerator and denominator, that will be the single term. So square root of 1 minus sine theta, the whole square is 1 minus sine theta. Square root of cos square theta is cos theta. See, this can be the answer of this question, and that is why I say please check the RHS. Sometimes they can give this, if they want to frame this question as a 1 mark question, they'll give till here, answer again. We don't have to wait for second tan to get, right? That's why I don't buy hard anything. So now I want second tan, but I don't want sine and cos. One. Secondly, I don't want the denominator there. There is a denominator here, so obviously I will separate the denominator. What is 1 upon cos? We know as per the relation it is sec theta. And what is sine upon cos? It is tan. The relations used, please mention it in the bracket. Tan is equal to sine upon cos. This is equal to RHS. Therefore, square root of 1 minus sine upon 1 plus sine is equal to sec theta minus tan theta. Is it okay? Again, I will keep this, erase it. Now let us go to the fourth one. Prove that sec theta minus cos theta into cot theta plus tan theta is equal to tan into sec. Now again, we have to observe whether we can apply identity directly or not. Not possible because there are no squares there. It's not a typical problem, but a basic one. If you observe, brackets are in multiplication and we want tan and sec. So what we can do is we can either in this step only convert everything to sine and cos or expand it. There are two brackets in multiplication, x minus y, a plus b, x into a, x into b, y into a, y into b. 4 terms you'll get, and then convert everything to sine and cos. That is your choice. So sec theta into cot theta plus sec theta into tan theta minus cos theta into cot theta minus cos theta into tan theta. Minus into plus is minus. Minus into plus is minus. Now if you observe, we have the answer in the question. Tan and sec. Tan theta into sec theta is my RHS. What does it tell me? That these three terms will cancel. Okay, let us solve further. Convert sec to cos. 1 upon cos theta What is cot theta? It is cos theta upon sin theta. The next term I won't convert because that is my RHS. Minus cos theta as it is. Cot theta will be cos theta upon sin theta minus cos theta, and tan is sin upon cos theta. So I converted everything to sin and cos except this term. Cos gets cancelled, cos gets cancelled. So what we get now? 1 upon sin theta plus tan theta into sec theta minus cos square theta upon sin theta and minus sin theta. Now let us bring together these two terms. 1 upon sin theta minus cos square upon sin theta minus sin theta in the last term, which is our answer, tan theta into sec theta. These two only are the denominator, so sin theta 1 as it is, denominator is same, minus cos square because denominator is same, minus sin plus tan into sec. As per identity, what is 1 minus sin cos square? It is sin square theta upon sin theta minus sin theta plus tan theta into sec theta. The identity used is sin square plus cos square is equal to 1. So one sign will get cancelled. So now what remains is sin theta minus sin theta plus tan theta into sec theta. So sin will also cancel, same term with different sign. So the result is tan into sec, which is RHS. I hope you understood what it is and how to solve it. Next, I would like to solve question number 7 of this exercise. Question is, sin raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. I'll go with LHS. It's not necessary that you take LHS every time. It is your choice. Any given problem can be solved both ways, taking RHS and getting up to LHS or vice versa, but 90% of the time it is advisable to take LHS and solve the question. Again, as I said, I'll check the RHS. If you observe RHS, there is no sign in RHS. It is 1 minus 2 cos square theta. That itself tells me that I should convert this sign to cos. Now, if I want to convert it to cos, then I have an identity, that is sin square plus cos square is 1. But remember one thing, sin square plus cos square is 1. Sin plus cos is not 1. Sin raised to 4 plus cos raised to 4 is not 1. Sin raised to 8 plus cos raised to 8 is not 1. It is only applicable for a square of sin and cos. Sin square plus cos square is 1. It means I have to convert this raised to 4 to square, which will be sin square the whole square. I won't convert this presently, I'll keep it as it is. Because I want cos, I'll not do anything with it. Sin square the whole square. As I know, sin square can be converted to cos square. It is 1 minus cos square. So it will be cos raised to 4 theta as it is. The identity used is sin square theta plus cos square theta is equal to 1 minus cos square theta the whole square. It is of which form? Now in few problems of trigonometry, the identities which you have studied in 8th standard, chapter number 8, chapter identities in 8th standard there was. Algebraic expressions, chapter number 5 and 6. In that, these identities have come and you have studied. So it is of which form? It is of form a minus b the whole square. And what is a minus b the whole square? We can write a minus b the whole square is a square minus 2ab plus b square. The same to be applied to this bracket. A is 1, so 1 cos square is 1, minus 2 into 1 is 2, b is cos square theta, plus cos square is cos raised to 4 theta, b square. And the term which is there, which is cos raised to 4 theta with a minus sign. So this is positive, this is negative, will get cancelled. What will remain is 1 minus 2 cos square theta, which is RHS. Therefore, sin raised to 4 theta minus cos raised to 4 theta is 1 minus 2 cos square theta. Very easy. Observe RHS and simplify. You will reach RHS easily. Then let us solve the 10th one of that exercise. Tenth one. Do that. Tan A upon 1 plus tan square A the whole square plus cot A upon 1 plus cot square A the whole square is equal to sin A into cos A. I take LHS, obviously the single term on the left hand side, on the right hand side, it's advisable to take a LHS and simplify. Now, a particular trigonometric problem can be solved in many ways. A few problems, as I said, the type 3 problem, there a particular method is easier to apply, and if you apply that, you can get answers quickly. But otherwise, a trigonometric problem can be solved in different ways. Sometimes you convert every problem to sine and cos. Sometimes you apply identity. Sometimes you apply identities studied in lower standards. Those identities for a formula and all that. So there are different ways of solving a particular problem of trigonometry. In this case, there is tan A. As I want to simplify this and get to a single term, I'll think of the identities if I can apply, because there are square terms in the given question. 1 plus tan square A obviously is an identity form, and what is 1 plus tan square A? It is sec square A, the whole square. Don't forget there is a square, you have to mention it. 1 plus cot square A is cosec square A, the whole square. Please write down the relation or the identity which you have used, and while writing it, though the question is in A as an angle, you should write it in theta, because the identity is always written in theta form. 1 plus tan square is equal to sec square theta we have used, and 1 plus cot square theta is equal to cosec square theta, these two identities. Now it is tan A sec square का square is sec raised to 4A cot A cosec square का square it is cosec raised to 4. RHS is sin and cos. So obviously I convert everything to sin and cos. Easier for me to simplify. What is tan? It is sin upon cos. What is sec raised to 4? 1 upon cos raised to 4. Reciprocal. What is cot? Cos upon sin. What is cosec raised to 4? 1 upon sin raised to 4. Again, the relations which we have used, all four of them, tan theta is sin upon cos, cot theta is cos upon sin, sec into cos is 1 and cosec into sin is 1. All four to be mentioned. So now what it is sin A upon cos A. This is division by 1 upon, so multiplication by cos raised to 4 upon 1. This is cos A upon sin A, division by 1 upon, so multiplication by sin raised to 4 upon 1. Cancellation, cos will cancel, this will become raised to 3, sin will cancel, it will become 3. So what remains is now sin A into cos cube A plus cos A into sin cube A. As I want sin A and cos A in the right hand side, I can simplify this by taking common. What is common? The lowest power of a term is common, always. Here it is sin, this is one term, this is another term which has sin cube. The lowest power is sin A. It is cos cube, this is another term which has cos, the lowest power is cos. So what remains inside this bracket? From this term sin A is common, from cos cube A we have taken cos A, so what remains is cos square A. Cos A we have already taken common, from sin cube A, sin A is common, so what remains is sin square A. So sin A into cos A. And what is cos square A plus sin square A? 1. It is an identity since sin square theta plus cos square theta is equal to 1. So the final result is sin A into cos A, which is RHS. Is it okay? Then we'll solve question number 12. The last of this exercise, a unique one because there are 3 terms on the left hand side. Question number 12. Prove that tan theta upon sec theta minus 1 is equal to tan theta minus sec theta minus 1 upon plus sec theta plus 1 upon tan plus sec theta minus 1. When such question, not necessarily tan and sec, this same question can be framed in cot and cosec. The same question can be framed in cos and sin. 3 identities. Because there is an identity between tan and sec, it is framed in tan and sec. There is an identity between sin and cos, it will be framed in sin and cos. There is an identity between cot and cosec, it will be framed in cot and cosec. Now if it is framed in tan and sec, and there are 3 terms on the right hand side, I will not prove in a normal way which we have done till now. That is taking LHS simplifying. No. We are going to use identity directly. We have 1 plus tan square theta is equal to sec square theta. This is the identity. Now what we want, I'll go according to LHS. we want sec minus 1. To get that, let us bring this 1 on this side. So it is tan square is equal to sec square theta minus 1. Now if you observe, there is no square term here, it is tan and sec. So to get those terms, this is okay. Presently I will keep this as it is. But what about this? Sec square minus 1. What is sec square minus 1? It is of the form a square minus b square. I will write it as a minus b into a plus b. We can mention it here. A square minus b square is a minus b into a plus b. So, if you observe now, there is a tan square, there is sec minus 1, there is sec plus 1. I want denominator में sec minus 1 and numerator में only 1 tan. So from this tan square, I will take 1 tan. Denominator sec theta minus 1. What remains on the right hand side? Sec theta plus 1. And this tan square, 1 tan is gone, the other tan will come here. If I cross multiply, I should get the previous step. So tan into tan, tan square, sec minus 1 into sec plus 1 is my right hand side. We got this. Now, to achieve this, 3 terms. You have studied in 9th standard ratio proportion chapter a concept called theorem on equal ratios. These two are equal ratios. Apply an operation in the numerator, same applied in the denominator, the resulting ratio is equal to these two ratios. Now if you observe, it is tan plus sec plus 1. I have sec plus 1, I have tan, only thing I have to add these two. So by theorem on equal ratios, tan theta upon sec theta minus 1, sec theta plus 1 upon tan theta will be tan plus sec plus 1 and denominator same, sec minus 1 plus tan. You have to add it. This ratio, the resulting ratio is equal to both these ratios. Now let us compare this to the right hand side. Tan plus sec plus 1, yes it is same. Sec is positive, sec is positive, minus 1, and tan is positive, tan is positive. The only thing is we have to shuffle it. So this will come as it is the LHS of our question will be tan plus sec plus 1 upon tan plus sec minus 1. Very important. That's the way I address it. Actually, it is hence proved. Just to remember, I normally say it as very important. So that's the way we solve this problem. We have done the first exercise of chapter trigonometry. In the next video, I'll come up with few problems outside textbook of this particular exercise. We'll first solve those and then we can move on to the next exercise, that is application of trigonometry. I hope you have enjoyed this particular exercise. Any queries, any doubts, you can post. We'll get those solutions as early as possible. Thanks for watching. We'll meet next time. Bye. This is my first video I am posting. If you have liked this particular topic, if you subscribe it, if you like it more and more, then it will motivate me to post more and more videos of different topics related to maths. Let us meet again to enjoy another topic. Thank you very much.